Okay, Cloud Gurus, authorization, or Author Z if you're trying to sound like one of the cool kids. Well, this is where we really meet RBAC. Now, there's more to Kubernetes authorization than just RBAC. Like, if we look here, we can see that my Docker for desktop cluster is configured with Node and RBAC. Now, we'll get into RBAC obviously, but the node authorizer is a way of controlling the access that kubelets have to the API server. Sort of getting towards like a least privilege for nodes, yeah? Anyway, as well, you can obviously have more than one configured, and it's generally accepted that these two should be the minimum. Okay, well, RBAC. GA since 1.8, so pretty mature. But you know what? Apparently still a bit complex, or at least it seems that way when a lot of people look at it for the first time. But you know what? Like I think I said with maybe storage, if you get your head around a couple of concepts, it's really not that hard. So the architecture of the model is like this. Which users can perform which actions on which resources? That's RBAC. Now, in the native Kubernetes lingo, we call users and groups here the subject. The operations are verbs, HTTP methods, yeah, so put, get, and all that jazz. And resources are things like pods and deployments. And it goes like this. On a cluster with RBAC enabled, if I was to create a new user, in fact, you know what? Give me a second here and I'll just open up my kubeconfig file. You can see the same with kubectl config view. It's just a bit easier to show you in an editor. Anyway, we've got some clusters configured and then some contexts. So if I created a new context, and I wouldn't do it manually, I'd use kubectl, but if I created a context for, say, whatever, right, my Docker for desktop cluster, yeah? With a user called Nigel, and then I came down here and I added some creds for the user. Even if those creds were valid and accepted by the cluster, I still would not be able to do anything. Because by default, that user's got no permissions. So yeah, I might well be able to authenticate, but RBAC's going to have me locked out, right? Denied by default, yeah? So if we want that user to be able to do stuff, we need to explicitly create some allow rules. Alright, but I mean, we're a pretty good way through the course now, and if you've been following along, you've been doing all kinds of crazy stuff, and you've not been locked out, so what's the crack? Well, what happens is, when you create a new cluster, you get a context and a user that has got mega permissions. And that's all good, right, for labs and the likes? But it is the opposite of what you need for production. So you need to create users and start opening things up. So taking an RBAC enabled cluster and a new user, Nigel or whatever, yeah? We need to create two objects to grant permissions, roles and role bindings. And these are the two things that if you get your heads around them right, are going to make RBAC like a Sunday afternoon stroll in the park. Let's look at the role first. As we'd expect, right, it's a REST resource in the API. Oh, and it lives under the RBAC.authorization API group. It's namespaced and it's got a name. Now, the important stuff. Roles are about the rules. And this one's granting permission to get, list, and watch pods. And pods have been around since forever, so they're in this legacy core group here indicated by the empty quotes. If it was deployments, for example, it'd be under the apps API group. Anyway, look, it's a standard config file, so we deploy it with kubectl. Brilliant. And if we think back to RBAC being about who can perform which operations on which resources, well, we've got the which operations on which resources, get, list, and watch on pods in the ACG namespace, yeah? But we haven't got the who. For that, we need a role binding. This is like the glue that connects the operation in the resource bit with the authorized user. So again, it's a resource under the same API group. A name and a namespace. Then under the subjects, we say, okay, we are binding a user called nigel@acg.com to this role, which we created earlier, yeah? Whew, boom. That's it. That is our subject. They can do these operations on these types of resources. And right there, Cloud Gurus, I give you role-based access control, the basics at least. Authenticate this user here, get this access to these resources. Magic. Now, there's a bit more to it, like, well, under role bindings here, we can use groups as the subject. And you know what? We can throw a bunch of them in as well. And it's kind of the same on the role side with multiple rules. Now, okay, this combination doesn't really make sense, I get it. And in fact, you know what? It's not even a great practice to use wildcards like this. I mean, we're giving admin here, really. Every action on every resource in every API group. I mean, okay, it's namespaced, but it is effectively omnipotent within that namespace. But you get the point, right? You can list multiple rules. Now then, as well as roles and role bindings, we've got cluster roles and cluster role bindings. But don't sweat, right? They are exactly the same as what we've already seen, only they're not restricted to a namespace. So that means if we switch these two kinds up here to be the cluster versions, we need to actually rip out the namespace values as well, because they apply cluster-wide. Which is all well and good, but this rule down here just got a lot more dangerous, because now it's admin to the whole cluster. But that's the deal. Namespace scoped and cluster scoped. And a good practice here, right, is to maybe define roles as cluster roles, but then attach them to users via namespaced role bindings. That way it just lets you define a role once, but then use it as many times as you want in different namespaces. And that really is the crux of RBAC. However, stick with me for maybe a couple more minutes. I just want to mop up a few odds and ends. Now, I think I mentioned before, when we spin up a cluster, we get some default credentials and somehow they are mapped through to permissions on the cluster. Well, guess what? Now we've got the tools to see how that works. So I've got a context here, Docker for desktop, and it's the same on other platforms. Yeah, Kubernetes is Kubernetes, remember? But if I look in my kube config file, I can see that it's associated with a user with the same name. And the user's got some creds, and as it's the user for my current context, it's the user that all my calls to the API server are going to authenticate with. Marvelous. But that user needs some permissions on the cluster, yeah? Well, we know all about that now with roles and role bindings, and it just so happens that every shiny new cluster gets a bunch of pre-created cluster roles and cluster role bindings. And at the top here, we can see one for Docker for desktop, yeah? Now, your user's going to be different on your cluster, remember? But if I dump out the YAML for this object, so I guess the authenticator here has added the user to the system service accounts group. Fair enough, so we're actually binding all members of the system service accounts group. I'm not saying this is best practice here, right? But we're binding all of those users to a cluster role called cluster admin. And we can look at the YAML for that as well. Boom. All verbs on all resources in all API groups. So all-seeing and all-powerful, yeah? Great for labs, not so much for day-to-day production, no? And you know what? We're running a bit long, so I think I'll bring this to an end, right? RBAC, it denies everything by default, but we get around that by using all-powerful pre-created accounts. Fabulous for labs, maybe? But for production, you're definitely going to need roles and role bindings that grant specific permissions to specific users and groups. And you know what? We'll demo it in a minute. But before that, we're going to have a cheeky look at admission controllers.